So this question is a very good example of a question that looks very complex, but when you break it down, it's actually not too difficult. If we read our question, the drawing is an Alantic Homecare trademark shown, and it's an ellipse and a parabola. The curve ABC is our ellipse, so there's ABC. So as you can see, it's a partial ellipse, and we're told we have a minor axis of 80 mil, and we can see this here. Now, as you can see, you were not given the major axis. All right, so we're going to start off. We have a minor axis of 40, so that's what we're going to start off on our page. Oh, sorry, we have a minor axis of 80, so we're going to put 40 onto our page. And when we get that point, we're just going to draw in my minor axis now. And once we have that line, we're also going to draw in the line that the major axis will lie on. We do not have the major axis, but we know it's going to lie on that. We have 2 points at the moment on the curve. We have those 2 points. Now, if we look back to our question again, we are given point A, and point A is a point on the ellipse. If we look here, if we go down 25, so we're going down 25, we're going over 36, 70, and then we have a 15. So, sorry, that's 35. So 35 and 70 is 105, and 15 is going to give us 112. So we're going to go down 25 and over 112. Oh, sorry, 120. And we're going down 25 from this point here, which is the center point of the ellipse. 25. And over 120. And that there now has given me point A. Now, we know that if we have a major circle and a major axis, minor circle, minor axis. Point A is in my bottom left, so I'm going to use the bottom left. I'm going to draw a random line. Where my random line hits the major, I go parallel to my minor. Where it hits my minor, I go parallel to my major. That gives me point A. So if we look here, okay, I have this point A. There is a line from point A drawn, and that line is parallel to my major, and it touches my minor. So I have that here. So that's this line. This point then joins to my center point and is extended. And from point A, we have a vertical line which is parallel to my minor axis. So that's this, and then join this back to my center point. And that's how we find our major circle. So once we find our major circle, I'm going to put the point of our compass and draw in our major circle. Now I'm going to extend this line here that my major axis must be on, and as we can see here, that there is a point now on my ellipse. So I have 1, 2, 3, 4 points on my ellipse. I need to get some points here. Now, the ellipse I'm looking for is going from here to here. So I'm just going to focus on the quadrant, this left quadrant here. So I'm going to go 30-degree line. Just going to extend on, my major circle. And a 60-degree line. Sorry. Where it hits my major, go parallel to my minor. Where it hits my minor, go parallel to your major. Where it hits your major, parallel to your minor. Where it hits your minor, parallel to your major. If your construction lines go over each other, that's perfectly okay. And that's after giving me my ellipse curve. I'm going to darken in this point. Lovely, and that's the portion of the ellipse that I require. So the next thing I'm going to do, and it's very important, lads, please include our freehand sketch. Okay, please include the freehand sketch. Very important. Now, if we go back to our question, I have a parabola. My parabola is going from A to C. My parabola is going from A to C, and point A is the vertex. So A to C, and point A is the vertex. So as you can see, we're going to put a parabola inside this rectangle. So what I'm going to do is I'm going to start off by dividing up this side here. So a random line, and we're dividing up here. I've drawn a random line from here. It could be drawn from there. Get your compass, put any distance on your compass. I like dividing it by 4, but you do not have to use 4. At this point here, which is the last point, you join that back to the point on your line that you're dividing up. We're then going to use sliding set squares to create scalene triangles. The scalene triangles are equal in angle but not in size. That's given me 3 points. This point is closest to my vertex, so that's going to be 1, 2 and 3, and I'm going to join 1, 2 and 3 to my vertex. Lovely. I'm now going to divide down this line. Now you could divide up here, it's the exact same, but we're going to divide down here. Random line. Mark it off. 1, 2, 3 and 4. So we're going to join our last point here to that point just to get our scalene triangle. And from our other points we're also getting our scalene triangle again. Now that's given us 3 points. As we can see, this is 1, 2 and 3. 1 is always the point closest. In this case, these lines are going parallel to my axis. The axis is the midline which would separate your parabola. 1 joins to 1, 2 joins to 2, 3 joins to 3. Now I like to lightly draw my parabola curve in first before I darken it in. That's just so I have a path to follow. And that there is our ellipse and our parabola. Now, as you can see from the rest of the question, there is also an A which has to be constructed, but I'm going to leave that to you to go through.